Right, this one we're summing a GP. We have to find the sum of the first 10 terms of this geometric progression, 6 plus 24 plus 96, etc. All right, now, we know that what A is equal to 6, and the common ratio is simply 24 divided by 6, which is 4. So we need the formula to work out the sum in terms of GP. So there's two of them. We've got this one, Sn is equal to A outside of R to the power n minus 1 over R minus 1. Or you can just turn these around and do this. You might say, well, what would you do that for? Well, there's a nice good reason for it. When the common ratio is a whole number like 4, this is the best one to use because you'll see you'll get a 4 minus 1, which will give you a 3. Down here it'll be a negative, and you want to avoid the negative signs. However, if that was not 4, but say a quarter, then it'll be the opposite. This will be negative, okay, and that'll be positive. So you use this one for whole numbers, and this one for a fraction between 0 and 1. All right, okay, so let's go ahead with this. And we're going to work out the first 10 terms. So S10 is equal to the first term is 6 into common ratio is 4 to the power 10 minus 1 all over, and common ratio is 4 minus 1 is 3, and that gives me 2 outside of 4 to the 10 minus 1. Now when you do that in the calculator, you get the number 3,145,725. Quite a large number, isn't it? Because the geometric progression is going up each time, multiplying each time by 6. You could have done it from the beginning here, but you've got to go about 10 times, and which takes a bit of time, which is much, much faster. Okay, done. Right, in number 2, we have to find the number of terms needed for this sum to total 108251. Now we can see this is the GP because it's being multiplied by 3 each time. So we've got our A is equal to 11, and our common ratio, 33 divided by 11, which is just 3. Now because it's equal to 3, we're going to use this formula. Sn equals A outside of R to the n minus 1 all over R minus 1. So we know that this is a big number. 108251 must be equal to 11 outside of the R, which is the 3, to the n minus 1, all over the R minus 1, which is just 2. Now dividing that by 11, we're going to get 9841 equals 3 to the n minus 1 over 2. So 3 to the n minus 1 is equal to 19682. So 3 to the n says 19683. Now you could use logs to work this out, taking logs of both sides, etc. But with GPs, it's probably just easy just to put this into a calculator. So try various values, and when you put in n equals 9, that gives you that result. Okay, done.